Welcome back. Today we will be talking about the graphs of rational function, which is unit 4.2 in your textbook Algebra with Trig. So a few important things that you need to keep in mind for the rational function, that it will never cross a vertical asymptote. Graph may or may not cross a horizontal asymptote or slant asymptote, but there can be many vertical asymptotes. Graph will have at most one horizontal or slant asymptote. So as it says, there can be many vertical asymptotes, but there is a restriction on how many horizontal or slant asymptotes will be there. When we have to graph, we also need to keep in mind the intercepts. So intercepts, how the intercepts will work when we are talking about the x-intercepts and the y-intercept. So if the function is defined at 0, y-intercept at f of 0, right? So Rf implies rational function will not have a y-intercept if the function is not defined at 0. When we are talking about the rational function, we are talking about the quotient, right? Numerator and denominator. When we are talking about the x-intercept, at the input that results output to be a 0, that implies when the numerator of the rational function is equal to 0. What happens? Because a fraction will be a 0 only when the numerator is 0, right? But if 0 is in the denominator, it becomes undefined. 0 is under, that is undefined. So taking these as the basis, finding the intercepts and the asymptotes, there are certain steps. If you follow these steps, then the graphing will become a little bit easier. So number one step would be to factor the numerator and denominator whenever it is possible. In some rational functions, it will not be possible for you to factor, but if it is possible, please factor it out. Because when you factor it out, it will help you to find out if there is any hole in the graph, right? So to get a point of hole, or where there can be a hole, a possible hole on the graph, that can be figured out with the factoring part. And the factoring part will help us to get the vertical asymptote and horizontal asymptote more accurately. So to find the y-intercept, we are setting the x is equal to 0. That will give you the y-intercept. And then the next step is to find the x-intercept by where each factor of the numerator is 0. So basically, when we are talking about finding the x-intercept, we are putting the y is equal to 0. So if you have a fraction, and we are fraction is nothing but the rational function. If rational function in this case, if we put it equal to 0, so denominator will automatically be a 0, right? With the cross multiplication. So we are only putting the numerator equal to 0 technically. So that's why it says where each factor of the numerator is 0. So basically y is equal to, we are putting y is equal to 0. Then we need to find the vertical asymptote and the horizontal asymptote, or slant asymptote wherever it is applicable. We will discuss more in detail about how to understand the vertical asymptote, horizontal asymptote, and slant asymptote in a couple of minutes. Then the next step will be to find the removable discontinuity, or where the hole is. The same thing that we did in step number 1. And removable discontinuity, or where the denominator is equal to 0, these are my restrictions. So write all the restrictions, whether it is a vertical asymptote, where it's a horizontal asymptote, write everything down. And especially if there is a hole, write it down. And as I mentioned earlier, you need to factor the numerator and denominator to find the possible hole in the graph. And then finally, we can make a lovely sketch by using X and Y table. We can plug more points on the X and then see how the Y is behaving. So these steps will really help you. So the basic parent graph of a rational function is something like this. So if you have a basic understanding of the rational function, then the things will be a little bit easier. Let's understand it a little bit more by taking one example. Okay, let's see. So example number 1. Let's have a g of x is equal to 3 divided by x minus 2. And we will follow each and every step closely. As you can see, you cannot factor the numerator or denominator. It is already in the factored form. So there is no need for the step number 1 to factor. I can directly try to find out the y-intercept. When we are talking about the y-intercept, we are putting the x is equal to 0. So when x is 0, we are left with negative 3 half. Now the second step is to find the x-intercept. How to find the x-intercept? Put y is equal to 0. In this case, if you put y is equal to 0, then if you cross multiply, we will not get any x-intercept. So if I put 0 is equal to 3 over x minus 2, and if you do cross multiplication with 0 times x minus 2, 0 is not equal to 3. So that means the graph will not have a x-intercept. There will not be a point where y will be 0 and x will have a point. For horizontal asymptote, because we are using big on bottom. We have discussed about the horizontal asymptote, the 3 conditions of horizontal asymptote in the last video. So big on top, that implies horizontal asymptote is at 0. For vertical asymptote, put the denominator equal to 0, and that will give you x is equal to 2. Now, do we have any slant asymptote here? No, because the slant asymptote will happen when the highest power of the denominator is exactly 1 degree higher than the highest power of the numerator. So that means that the highest power of the numerator, if it is x squared and the highest power in the denominator is x, then we are looking for slant asymptote. So let's create x and y table. Remember when we did bot, pops, and sauce in the last video? So we are talking about big on top. So those are the cases for slant asymptote. So I'm using bunch of x values. I took negative 4, 0 is already there. Then we took 1, 2, let's take 2 more. 2 is undefined because we have vertical asymptote. Let's take 3. So 3 will give you 3 only. And then let's take 1 more, which is 5. I have these points, and I have understanding of the basics of how the parent function of a rational function looks like. So based on that, if you graph it, your function will be something like this. And as you can see from the graph, we have a vertical asymptote at x is equal to 2. That is a vertical dotted line. Then we have a horizontal asymptote at y is equal to 0. And then we have all of these points. So try to graph on your own, and then you can see if your graph matches or not with using the graphing calculator or any online graphing tool. So as you can see, this point is 3, 3. That is there on our table, x and y table. Then we have 5, 1. And then we are looking for negative 4, negative 1 half. So this is just the basic start of how to sketch a rational function. Right? If you plot all the points properly, if you have all the asymptotes and intercepts, then the things will be a little bit easier. Now let's take the case of slant asymptote. Slant asymptote, they are also called oblique asymptotes as well. And as I said earlier, when the degree of numerator is exactly 1 more than the degree of the denominator, just like bot, right? Big on top, then we are looking for slant asymptote. It's exactly 1 more than the degree of the denominator. So to calculate the slant asymptote, we use a technique that we have learned earlier, the long division, or you can also use synthetic division. So whatever is convenient for you, go for it. Let's try one problem and see how we can understand after long division and synthetic division, which part will be our will be our slant asymptote. So in this case, in this particular question, if as you can see, we are talking about bot, big on top. So the highest power is 2 in the numerator and the highest power in the denominator is 1, and they have a difference of 1. So let's try long division. X squared minus x will go inside the house and x plus 1 will stay outside. You can stop the video right here and try to do the long division on your own and then come back and check the answer with me. Remember, when you are multiplying it, don't forget to subtract. You are multiplying and then subtracting. That is the rule for long division, right? And then finally we'll get the remainder of 2. And we can write it down as the answer is x minus 2 plus 2 divided by x plus 1. So the x minus 2, this is what our slant asymptote is. So the graph will have a slant asymptote, y is equal to x minus 2. And x minus 2 is nothing but a linear line, y is equal to mx plus b form. So for the remainder, as x is increasing or decreasing without bound, the remainder which is 2 divided by x plus 1 approaches to 0. And once you have the slant asymptote, you can figure out more points. You can figure out the x-intercept, y-intercept, and then you can see, use the Desmos or graphing calculator to graph this basic function. Now, keeping this thing in mind, let's take one more example. So we are graphing f of x is equal to x squared minus x minus 2 divided by x minus 1. So first thing, we can factor it out. So the numerator will be factored as x squared minus x minus 2, and the denominator will remain as x minus 1 only. So we did the factoring part. The next step is to find the intercept. And after factoring, you can see I cannot cancel out anything. So we cannot cancel out anything. That means we are not looking for any hole here. So straight away, y-intercept will be 0, 2. The x-intercept, for the x-intercept, we are looking for the factors of the numerator. So what are the factors of the numerator? X minus 2 and x plus 1. So this will give you 2 x-intercept. Because if you put the whole entire function equal to 0 and the cross multiplication, denominator will be just a 0. Denominator will go with 0 and it will become a 0. So we will get 2 intercepts, 2 comma 0 and negative 1 comma 0. Now, step number C, we are looking for vertical asymptote. And how to get the vertical asymptote? Put the denominator equal to 0. We have a denominator as x minus 1. So it will be x is equal to negative 1 will be your vertical asymptote. X is equal to positive 1. Now, are we looking for a horizontal asymptote? This is the case of a bot, right? So whenever big on top, we are looking for a slant asymptote. So slant asymptote implies we are looking for long division or synthetic division. If you use long division or synthetic division, your answer should be something like this. It should be f of x is equal to x minus 2 over x minus 1. So you can pause the video again, do the long division or synthetic division, and see if you're getting the same answer. So from here, we can know the slant asymptote will be at y is equal to x. And that is a dotted line. After this, we can have some test points. And test points are nothing but creating x and y table. So take bunch of x values and then find the y values. We have few x values from the intercepts and the vertical asymptote. So we can use those. I took -2 as x, then -1 is the x-intercept, then 0 is 2, which is y-intercept, and let's take 0.5 or half. That will give you 4.5. And we know at 1 we have a vertical asymptote, so that is undefined. Then we have 1.5. That should give you -2.5. We have one more x-intercept at 2. Let's take one more point. So let's take 3. 3 will give you 2 as the answer. So now we have all the points ready. We can graph the function, keeping in mind the basic of parent function. But what will be the domain? Because we have a vertical asymptote at 1, so the domain will be all real numbers except x is equal to 1. So sometimes the questions might ask you implicitly, please define the domain and the range. But make it a habit to always write about the domain, right? You can graph on Desmos. I graphed it on Desmos, and the function looks something like, let me see where it is. Here you go. This is how the graph will be. As you can see, we have a vertical asymptote at x is equal to 1, slant asymptote at y is equal to x. And whenever we sketch the asymptote, we sketch it with a dotted line. So it is a good idea to use a color pencil, different color pencils, to show specifically where the asymptotes are. So this is how the graphing of the functions will look like for the rational function. Before we end the video, I'm writing one question down. Try it out on your own and check your answer on the graphing calculator. And I will see you in the next video. Bye-bye.